Good morning, dear students. Today we will start our new chapter, that is surface chemistry. The complete chapter is divided into two categories or two parts. Part first deals with adsorption, the surface phenomenon, and part second deals with colloids. So today we will start with part second, that is colloids. The term is not new to you, as this term was introduced in class 9th. There you were told about solutions or true solutions, colloids and suspension. On what basis the classification was made? The classification was made on the basis of size of particles present in the mixture. So if the particle size present in the mixture is less than 1 nanometer, then the mixtures are called true solutions or simply solutions. They are homogeneous in nature. Now move to colloids. When the particle size ranges between 1 nanometer to 1000 nanometer, then the mixture belongs to colloids, or the mixture are called colloids. And last one is suspension. If the particle size is more than 1000 nanometer, then the mixtures are called suspension. As in the suspension, the size of particle is more than 1000 nanometer. So force of gravity acts on that particles, due to which they exhibit the property of sedimentation. Settling down of particle under the force of gravity is called sedimentation. Two solutions are homogeneous in nature. The particles are uniformly distributed. Colloids are heterogeneous in nature. They are heterogeneous mixture, means distribution of particle is not uniform, and in suspension again it is your heterogeneous distribution of the particles. So solutions are homogeneous mixture, colloids are heterogeneous mixture, and the last one, suspension, is also heterogeneous mixture. So today we will talk about colloids and their types. Whenever we talk about solution, then we always talk about solute and solvent. Suppose sugar is added to water, then sugar gets dissolved in water. Sugar is called solute and water is called solvent. These terms in colloids are replaced by dispersed phase and dispersion medium. Like in solution, solutes are present in solvent. In the same way, in colloids, dispersed phase is present in dispersion medium. Like if we talk about starch salt, we are taking starch and dissolving it in lukewarm water. We will get a colloid which is called starch salt. Starch will form dispersed phase here and water will form dispersion medium. So solute is equivalent to dispersed phase of colloids. Solvent is equivalent to dispersion medium of colloid. So colloids can be defined as heterogeneous system in which one substance is dispersed that is called dispersed phase, as very fine particles in another substance called dispersion medium. Dispersed phase are the particles having size ranges between 1 nanometer to 1000 nanometer. So this is your colloids. Next is the classification. Colloids can be classified on three bases. Base first is the physical state of dispersed phase and dispersion medium. Like we classify solutions on the basis of physical state of solute and solvent. 3 states from solute, 3 states from solvent, 3 into 3, total 9 types of solutions are possible. But here it is 1 less than 9, total 8. Because gas with gas never forms colloid, it always forms solution. Because gases have the property of diffusion. By the property of diffusion, gases undergo homogeneous distribution. So mixture of gas with gas is always homogeneous in mixture. Homogeneous in nature. But colloids are heterogeneous mixture. So here we cannot take dispersed phase as gas and dispersion medium as gas. It will not give you colloid. Gas colloid is not possible. So total 8 types of colloids are possible. First one, dispersed phase solid and dispersion medium solid. Type of colloid is called solid solid. Dispersed phase is solid and dispersion medium liquid. It is simply called sol. Then we have solid gas combination. It is called aerosol of solid. Whenever dispersion medium is gas, we can use term aerosol with the type of colloids. So here dispersion medium is gas. Dispersed phase is solid, so type of colloid possible is called aerosol of solid. Then we have liquid solid. Dispersed phase liquid, dispersion medium solid. This is called gel. Liquid with liquid is called emulsion. Liquid with gas is called aerosol of liquid. Gas solid is called solid sol, and gas with liquid is called foam. You have to learn their examples also. But first you learn which type of colloid is possible when we have dispersed phase, solid liquid gas, and dispersion medium, solid liquid gas. So out of 8, 3 are more important. First one is your sol. When dispersed phase is solid and dispersion medium is liquid, this is called sol. Example, gold sol. Gold particles are distributed in water. Then opposite, interchange the physical state. Let us take dispersed phase as liquid and dispersion medium as solid. It is called gel. Jams, jellies are examples of gels. And last one is liquid with liquid. They are called emulsions. Then we have next classification, nature of interaction between dispersed phase and dispersion medium. Whether the dispersed phase is having affinity for dispersion medium or not. If dispersed phase is having affinity for dispersion medium, then the sol form or colloids formed are called lyophilic colloids. Lyophilic sol. They don't need any stabilizing agent. As dispersed phase is having affinity for dispersion medium. and they are reversible in nature. If dispersed phase and dispersal medium are separated by any physical method, then salt can be reconstituted by simply mixing dispersed phase with dispersal medium. So this is reversible in nature. Example, starch salt. The starch salt can be prepared simply dissolving starch in lukewarm water. We don't need any stabilizing agent. They are prepared by simple methods. Then we have lyophobic salt or lyophobic colloids. Dispersed phase does not have affinity for dispersal medium. They have repulsive interaction. And that's why we need stabilizing agent. We need a stabilizing agent for the preparation of colloid or lyophobic salt. Suppose we want to mix oil in water. There is no affinity between oil and water. Oil repels water. So how to get the emulsion? How to get the colloid? We have to add soap solution. Soap solution here will work as stabilizing agent, and then only we can get the colloid. These are irreversible in nature. If dispersed phase and dispersal medium are separated by any method, then simply mixing them will not give you colloid back, because they are prepared by some special methods. Some special methods are used for the preparation of lyophobic colloids or lyophobic salt. Example is your gold salt. Then we have third type of classification, type of particles of the dispersed phase. On this basis, these are classified into three types: multimolecular colloids, macromolecular colloids, and associated colloids. First one is your multimolecular colloids. What happens? Suppose if we want to talk about sulfur salt, then a single molecule of sulfur is very small. Its size is less than 1 nanometer. So single molecule of sulfur will not form sulfur salt. But if collection of sulfur molecules are taken, or if we get aggregates of sulfur molecule, then after the aggregation, the size of the particle will lie in range between 1 nanometer to 1000 nanometer, and we get the colloid. So here is your single molecule having dimension less than 1 nanometer, but when collection of the molecule is taken, then this aggregate particle is having dimension ranges between 1 nanometer to 1000 nanometer, and will form the colloid. So multimolecular, large number of atoms or molecules aggregate together to form species having size in colloidal range. Example, sulfur salt. Next one, macromolecular colloids. In macromolecular colloids, the dispersed phase particles are large enough. Their size ranges between 1 nanometer to 1000 nanometer. So simply adding them to dispersal medium, we will get macromolecular colloids. There is no need of aggregation. So here, macromolecules in suitable solvent form solutions in which the size of the macromolecules may be in the colloidal range. Example, starch salt. We can also use cellulose salt. It can be protein salt. It can be enzyme salt. Then the last one, that is associated colloids or micelles. The important part here, there are few substances which when added to a suitable medium or dispersal medium acts like electrolytes and forms true solution at low concentration. But at a particular concentration and a temperature, that concentration is called micellar concentration. They again form groups. They show aggregation, as a result of which they acquire the dimension of colloidal particle, which ranges between 1 nanometer to 1000 nanometer. So in multimolecular also we are having group. Here also group is there, but it is concentration dependent colloid. At low concentration we are getting two solution. The dispersed phase particle acts like electrolytes, but at a proper concentration, that is called micellar concentration, these particles form groups and gets converted into colloids. That's why these are called associated colloids or micelles. Remember here, a proper temperature is required for the formation of associated colloids. Below this temperature, you will not get associated colloids, and this temperature is called Kraft temperature. We require a minimum concentration of dispersed phase particle. This concentration is called critical micellar concentration, CMC. So two terms important here, CMC and TK. TK stands for Kraft temperature and CMC stands for critical micellar concentration. That's all in colloids and their classification. Thank you and have a nice day.